Okay, question 9 says an industrial steam cleaner costs $3,200 with diminishing value at 15% per annum. We need to calculate the amount of depreciation during the first year of service and the amount of depreciation during the 8th year, expressing this amount as a percentage of the purchase price. Okay, so clearly this is our principal, that's the first thing to note, and here's our depreciation rate, 15% per annum. The amount of depreciation during the first year of service, now it doesn't tell us at any point here whether it's flat rate depreciation or reducing balance depreciation, but since we're only working it out for the first year here, it doesn't matter. For the first year, flat rate and reducing balance are the same. They'll produce the same result. So let's work it out. Let's work out part A to begin with. So we've got depreciation equals PRT over 100. We'll use flat rate because it's easier to work with. And we've got 3,200 as the principal, we've got 15% as the rate, and in the first year the time is 1. And then divide all that by 100. Okay, when we put that into the calculator, 3,200 times 15 times 1, and then divide it by 100, we get 480. Okay, so in the first year there's $480 of depreciation. Now in the second part, this is a bit trickier. In part B we have to work out the amount of depreciation during the 8th year. Now part of the difficulty with this is it doesn't tell us whether it's flat rate or reducing balance, but I think we can assume that given we haven't been told which one it is, and they're asking us to work out the amount of depreciation in the 8th year, it makes sense to me that it has to be reducing balance, because if it was flat rate, it would be exactly the same in every year. Flat rate depreciation, the same depreciation occurs every year, so there wouldn't be anything to work out, and it would be strange to ask a question like that. It would just be the same as answer A. So let's assume it's reducing balance, in which case reducing balance, the equation is V equals P 1 minus R over 100 to the power of n. So we could try and use this equation, but the problem with this equation is it will give us the value at the end of the 8th year, and we can work out the depreciation that occurs during the whole 8-year span, but this equation can't tell us how much depreciation occurred just in that single year. Okay, this equation is not going to be able to do that for us. What we would need to do is to work out how much depreciation occurs in the first 7 years. So if here's our 8 years here, if we use this equation to work out how much depreciation occurs in the first 7 years, and then we'll have the principal, the amount, the value at the end of the 7 years, and then we can just do that last 8th year using this equation here, and we'll just get the depreciation for that year. So let's do that. So in this equation we're going to put principal is 3,200, 1 minus R is 15, and that's over 100, and it's to the power of 7. There's going to be 7 years. Okay, now you can see here the equation in the calculator, just as I've written it on the notepad here, and when we evaluate that, we get no solution because I forgot to put in comma and V. Let's try it now. Okay, V equals 1,025 and 85 cents. So 1,025 and 85 cents. Now that, let's make it clear, is the value of the steam cleaner after 7 years. It's not the amount of depreciation. So now we know after 7 years the value of the steam cleaner is this. And now if we want to work out how much depreciation would occur in the 8th year, all we need to do is use our D equals PRT over 100 equation, because that tells us depreciation for 1 year. We'll make P equal 1025.85, make R equal 15, and we'll let the time equal 1, and we'll see what that gives us. We don't need to do times 1, and then divide it by 100, 153.88. So that's how much depreciation would occur in the 8th year. And then finally we need to express the amount of depreciation in the 8th year as a percentage of the purchase price. So 153.88 divided by 3,200 and then multiply it by 100%. Let's see what we get for that. So 153.88 divided by 3,200 and then times 100%, we get 4.81%. There we go. Okay, in question 10 it says a motorbike is purchased by a courier company for $11,600 with reducing balance depreciation at 18% per annum. The trade-in value of the motorbike is expected to be $1,500. Okay, so this is our purchase price. That's P, and we've got reducing balance depreciation with that depreciation rate, and the trade-in value of the motorbike is expected to be $1,500. In other words, we've been told that the book value of the motorbike at the end of its life, I guess you could say, is $1,500. Find the book value of the motorbike after 3 years. Okay, so if we're doing reducing balance, it's going to be V equals P 1 minus R over 100 to the power of N. And in this case, P is 11,600, 1 minus R is 18, and N, if we're doing 3 years, then N is 3. So we can use, we had the equation earlier on, we can use the same equation, just change the values. So this is 11,600, and now the interest rate is 18, and the amount of time is 3. And we're still trying to find V, so we can leave that the same. We've lost it up here. There we go, 6,395.87. So for part A, that is the answer. In part B, we have to calculate the accumulated depreciation over this period. Okay, so the total amount of depreciation is going to be the purchase price minus the current book value. The difference between the original price and the current price is the amount of depreciation. So 11,600 minus 6,395.87 will give us the amount of depreciation. $52.04.13. So that's how much depreciation occurred in those 3 years. Okay, then finally, after how many years will the motorbike be traded in for a new one? Okay, so in this case we're trying to work out an amount of time. In other words, N is going to be the thing we don't know, in which case we have to know everything else. We have to know P, R and V. And earlier on we saw that 1,500 was the book value at the end of the motorbike's life, or when it's traded in. So that's going to be our value for V. So if we go back, we'll write out the equation again, putting in solve, and the book value is 1,500, the principal is 11,600, and then in brackets we've got 1 minus 18 over 100, and that's all to the power of N, which is what we're trying to find. And we need to tell the solve function that's what we are trying to find by putting comma N at the end of our equation. And we get N equals 10.31. N equals 10.31 years. And usually we like to express things in terms of years and months, because 0.31 of a year, that doesn't mean much. So we'll times 0.31 by 12, turn it into months, 3.72 months. Or we'll just round it off to 4 months. Okay, in question 11 it says a company writes off 22% per annum for reduced value depreciation of its machinery with a current book value of $606,820. What was the purchase cost of the machinery 3 years ago? Okay, so if it's reduced value, I think that is supposed to mean reducing balance, so we'll use our reducing balance equation. V equals P 1 minus R over 100 to the power of N, and here's our value for R. We're talking about a time span of 3 years, so that's our value for N, and it says this is the book value V. Okay, so it looks like we're looking for the purchase cost, which is going to be P. Okay, now when I tried doing this in the calculator using the normal method, using the solve function, the calculator didn't seem to be able to do it. So we're going to try something a little bit different. We'll do a little bit of paper working out first. So we'll put our value of V as 606,820, and then P is what we don't know, and then in the brackets here we've got 1 minus 22 over 100, and it's to the power of 3. Okay, now we want to get P on its own. We want to find out what is P. So in order to do that, let's first work out what's in this bracket here. Now another way of saying 1 minus 22 is to say 1 minus 0.22 to the power of 3. And then this bit inside the brackets would become 1 minus 0.22 is 0.78 to the power of 3. Now we've got P times all of this, and we want to get the P on its own. So let's just get rid of this from this side, 0.78 to the power of 3. Let's divide this on this side, get rid of it there, and move it over here. And then we've got 0.78 to the power of 3 over here. And now we've got P, an expression for P. P equals this number here. And if we put this expression into the calculator, then let's see what we get. We get 127.8721. 127.8721.8283. Okay, so this was the original purchase price of the machinery. Okay, in these two questions, they're multiple choice, but we'll work them out the same way anyway. The new computer station costs $54.90, 26% per annum, so we've got R and we've got P, and we've got reducing value depreciation, which I guess is another way of saying reducing balance. And the station's book value at the end of the third year will be close to, so we're after book value V. So it seems clear we've got to use reducing balance equation. V equals 54.90, and then in brackets 1 minus 26 over 100, and at the end of the third year, which means N is 3, if we put that into the calculator, let's see what we get. So we want to solve for V equals 54.90, 1 minus 26 over 100, and then we want to make all that to the power of 3. But I forgot to put the unknown was V, and to end it with the brackets. So there we go, V equals 2224.68, and that's clearly very close to answer B. Okay, then for question 13, we've got the value of a new photocopier is this, so that's our P. Its value depreciates 26%, that's R in the first year, 21%, so we've got another value for R and then another value for R here, reducing balance in the remaining 7 years. The scrap value of the photocopier to the nearest value is, so the scrap value is the final value, it's V at the end of its life. So it looks like there's 3 stages here. We've got to do the first year at 26%, so it doesn't matter if it's 1 year, it doesn't matter whether it's reducing balance or flat rate. So let's just do D equals PRT over 100 for the first year. We've got 8894, we've got 26, and we've got 1, and it's over 100. So 8894 times 26, we'll put times 1 just for the heck of it, and we get 2312.44. That's the depreciation in the first year. 2312.44 is the depreciation in the first year. So when we want to work out the depreciation in the second year, we're going to need to ask again, what's our P? And our P's, to find the cost of the photocopier in the second year, we're going to have to take the depreciation away from this number here. Okay, so P for the second year equals 8894 minus 2312.44. So let's work out our new purchase price. 8894 minus, we'll just put the answer from the previous line in, and we get 6581.56. 6581.56. So that's our new value for P. And now when we work out depreciation in the second year, we're going to do PRT over 100. That's going to be our P. So let's use the answer from the previous line, multiply it by the second year interest rate, which is 21%, and again it's 1 year, and then divide all that by 100, and this is the depreciation in the second year, 1382.13. 1382.13. So that's our depreciation in the second year. So again, let's minus that depreciation away from this to find the new value, the new book value of the machine. So it's going to be 6581.56 minus our answer from the previous line. So the new value is 5199.43. 5199.43 dollars. Okay, that's the value of the photocopier after 2 years now, and then 16% reducing balance for 7 years. So V equals P is 5199. We'll put 0.43 in there, and then 1 minus 16% over 100 for 7 years. So this will give us the book value at the end of those 7 years. So let's do solve. V equals 5199.43, and then 1 minus 16 over 100 to the power of 7, and then comma V. Okay, and it worked. We got V equals 1534.30. 1534.30 was the value for that, and that's very close to this one, D. Okay, in question 14, we've got some camera equipment purchased for this amount, so that's P. It'll have a scrap value of $9,000 in 5 years. So that's a book value at the end of its life, V, and the amount of time is 5 years. So that's going to be either N or T, depending on which equation we use. And we have to find the annual depreciation under flat rate and reducing balance depreciation. So we've got to do both of these types of depreciation. Now, one thing will be that under flat rate, the depreciation will be the same every year. So there'll only be one answer for this. But for reducing balance depreciation, it'll be different for each of the 5 years. So this one might be a bit more work to do. Let's start with flat rate, the easy one. Okay, so to work out the flat rate depreciation, the amount of depreciation, each year, that's going to be D. We need to know P, R and T and multiply them together, divide by 100. But a problem here will be that we don't know R. Okay, we can't work out D unless we know R. So there must be some other thing going on here. Well, this might be important here. We've got the purchase price and we've already got V. Okay, we already know how much the thing's going to end up costing. So let's use this other equation. The value of something equals its purchase price minus its depreciation, and we know that its value is going to end up at 9,000 and its purchase price was originally 150,000, so we can work out D using these numbers here. If we add D over here and add D over here and then minus 9,000 here and minus 9,000 here, then we end up with D equals 150,000 minus 9,000 is 141,000. Okay, so now we've got a value for D that we can put into this equation and we can work out R. So let's do that. 141,000 equals 150,000 times R times, we'll just do 1 year, actually that's got to be 5 years, and it's over 100. So we're going to have to use the solve function here because we don't have a nicely set out equation. We're going to have to solve it. Equals 150,000 times R times 5. And we've got to put all of that over 100. Okay, now we could have done it as using the fraction button here. I've done the same thing. There's the top part of the fraction in brackets divided by 100. Okay, we forgot to put in the comma and R at the end of the function, and then to close the brackets. There we go. R equals 18.8. 18.8 years. Okay, now that we know the interest rate, we can work out D, the amount of depreciation, because we weren't actually after the interest rate, we're after the annual depreciation, but we needed R to work out D. So now we've got D equals 150,000 times 18.8 times, we'll just do 1 year, because we want to know the annual depreciation just for 1 year. So we've got 150,000 times 18.8 times 1 for the heck of it, and divide it all by 100, 28,200. So for flat rate depreciation, that's how much depreciation occurs every year. Okay, for the second part of this bit, the reducing balance depreciation, because the reducing balance depreciation is going to be different each year, and we also don't know the interest rate, the depreciation rate, we're just going to settle for working out R for this situation. So if we have our equation for reducing balance depreciation, V equals P 1 minus R over 100 to the power of N. Okay, if we substitute in the values we've got V equals 9,000, we've got P equals 150,000, we've got 1 minus, we don't know R, over 100, and we've got N equals 5. If we use all of this, we should be able to find a value for R. Okay, so we put that equation into the calculator. There's V, P, R is unknown, and N is 5, and comma R because we want to know R, and it spits out this. R equals 43.03. R equals 43.03, and that's going to be a percentage, because R is always a percentage. So that's given us the value for R, and that's good enough for the answer to that. Now we need to graph the results for each type of depreciation on the same set of axes. Okay, in this video we're going to work through some questions from the textbook on depreciation. Here's question 1. We've got a machine that costs $286,000 and it depreciates at 16.5% per annum by flat rate depreciation. Okay, so that's important. We know it's flat rate depreciation, not reducing balance. Okay, we've got to calculate the book value of the machine after the first 2 years of service. Okay, so for question A, the book value, V, is going to be the initial cost, or in other words, the purchase price, P, minus the amount of depreciation. Okay, so we know the purchase price already was $286,000, so we've just got to work out the depreciation, and for flat rate depreciation, the formula is PRT over 100. So if we substitute those values in, the principal, the initial price was $286,000. The interest rate was 16.5% per annum, and we're talking about 2 years of service here. So T is 2, and it's all over 100. Now actually I should get rid of that equals there because this is just the depreciation, this bit here. Let's put that into a calculator. Okay, so the top line of the equation was 286,000 times 16.5 times 2. That equals that, and then we want to divide it by 100 and we get 94,380. So this equals 94,380. That was the amount of depreciation that occurred in those 2 years. So in our equation we want to replace, we've got 286,000, the amount of depreciation we worked out was 94,380, so we put that in there, and when we do that, let's do 286,000 minus our answer from the previous line, and we get 191,620. 191,620. So that will be the book value of the machine after 2 years of service. In the next one, calculate the total depreciation over the first 5 years. So notice with this question, we're not being asked to work out the book value this time. We're being asked to work out the total depreciation. So we don't have to do V equals P minus D. All we've got to do is the depreciation, which is that. It's that bit there. So PRT in this case is 286,000 times 16.5, and this time T is 5 years, and it's all over 100. When we put that into the calculator, 286,000 times 16.5 times 5 and divide it by 100, we get 235,950. 235,950. So that's the value that's been lost. That's the depreciation that's been lost in the first 5 years. And that's quite a lot, isn't it? It's not worth much now. How long will it take until the machine reaches its scrap value of $10,000? Okay, so this question's saying we know what the book value is going to end up to be. The book value is going to end up to be $10,000. That's its scrap value, so that's the value it's going to have when we get rid of it, and that's going to equal the initial cost, which is P, minus the depreciation. And P is still 286,000 minus the depreciation, which we know it's PRT over 100, and we're trying to work out what T is, the amount of time. We know what P is, we know what R is, we just need to know what T is. So let's put all that, let's write all that out. Okay, so we know that 10,000 equals 286,000 minus we'll put this in brackets, 286,000 times 16.5 times R, which we don't know, and that's all over 100. Alright, now we want to get rid of this 10,000 over here, so we'll minus 10,000 from both sides, and then we end up with 0 equals 276,000 minus all of that. And if we put it into a calculator, let's see what it becomes. So when we put that top line of the depreciation into the calculator, we get 4719. So 4719,000 times R, and then we want to divide that by 100, which means we just lose 2 of the zeros on the end. So we've got 47,190 R minused away from this equals 0. Okay, let's rearrange this equation so we can calculate R. If we minus this from both sides, then we'll be in a position to work out R. So we've got negative 276,000 equals 47,190 times R. And actually I forgot to put the negative in there, so there's a negative there. And then we want to get R on its own, so let's divide both sides by negative 47,190 to get rid of that. Got to do the same on the other side, divide by negative 47,190. And so we've got 276,000 divided by 47,190. And because there's a negative on the top and the bottom, I don't need to put them in, they're going to cancel each other out. We get 5.85. So R equals 5.85 years. That's how long it's going to take. Okay, and if we consider that this 5.85 years, maybe that's not an extremely meaningful amount of time. So let's convert 0.85 years into months by multiplying 0.85 by 12. And we've got 10.2 months. And it's probably better to round that up to 11 months, because 10.2 months we're not going to get there. In 10 months we're not going to get there. It's going to take that 11th month to get there. And we don't sort of want to go into fractions of months. So let's just say 5 years and 11 months, and then we will have reached the goal. Okay, in question 2 it says a building crane was purchased by a construction company for $450,000 and is expected to have useful life for 19 years. We need to calculate the crane's value at the end of 16 years of service if it is recommended flat rate depreciation rate is 5% per annum. Okay, so this seems like a pretty straightforward problem. We just need to calculate the book value of the crane, and we know its purchase price already, and we've just got to work out its depreciation. The purchase price was $450,000, and D will be equal to PRT over 100 because this is flat rate depreciation. So P is equal to 450,000 multiplied by the interest rate, the depreciation rate, which was 5%, and the number of years is 16, and then divide all that by 100, and we get 360,000. And if we put that into our equation up here to find the book value, then we get $90,000. That's the value of the crane after 16 years of service. And this 19 years was a bit of a red herring, it wasn't really important. In question 3 it says a factory writes off 4% per annum for a building that has a current book value of $310,000. If the adopted method to calculate depreciation is flat rate, what is the book value of the factory building in 11 years' time? Okay, so again, the book value will equal the purchase price minus the depreciation. We've been told that the purchase price, or it's the current value in this case, is $310,000. That's what it's worth now, and it's going to depreciate. We just need to work out what that amount D is using flat rate depreciation, and that D is going to equal PRT over 100, which will be 310 times 4, and it's 11 years divided all by 100. Maybe to make it simple, we'll just cancel out some of these zeros to begin with. So $3,100 times 4 times 11 gives us 136,400, and I don't need to divide by 100 because I've already cancelled out those zeros. 136,400. So that's our depreciation. Let's just get rid of that and replace it with 136,400. And then when we put that into the calculator, $310,000 minus 136,400, we get 173,600. Okay, in question 4, we need to work out the yearly depreciation expense of a computer that's worth $5,200. It's depreciating at a flat rate of 30% per annum. So for question 4, we only need to work out the depreciation here. So D equals PRT over 100. P is 5,200. R is 30%, and the amount of time, we're just trying to work it out for 1 year, the yearly amount. It's going to be the same for every year with flat rate depreciation. So let's simplify that a little bit. Okay, so we've got 52 times 30, and that's it, 1560. So every year, this computer will lose $1,560 of its value, and that's answer B. In question 5, we've got, given that D equals depreciation, P equals purchase price of an asset, and T equals period of depreciation, then the constant rate depreciation R can be calculated using this formula. Okay, so what they've done is rearranged the D equals PRT formula to find R, to isolate R. So if we were going to do that ourselves, then we'd go times 100 times 100, and we'd have D times 100 equals PRT, and then we'd need to get R on its own by dividing P and T over here, cancelling out the P and the T, and so we've got D times 100 divided by PT. Or they've written it this way, 100D divided by PT. That's that one there. So the answer is C. Okay, in question 6 we have to find the depreciation of the following assets. So the purchase price was $2,600, flat rate depreciation, 20% per annum for 2 years. So for A, D equals PRT over 100, and that equals 2,600 times 20 times 2, and it's all over 100. Cancel out some of those zeros. So we've got 26 times 20 times 2 gives us 1,040. Now we're only being asked to find the depreciation of the following assets, so we don't have to do anything minusing 1040 from 2600 here. We've answered the question just by doing that. $1,040. In B, we're going to have a similar situation. I think we can go straight to the calculator now. So we've got 18,200 times 18, and it's for 4 years, and divide that by 100. 13,104. In C, we've got a purchase price of 136,000. So we'll put in 136,000 times 5.25 times 13 years, and divide it by 100, and we get 92,820. And finally, in D, the purchase price is 15,612, and the interest rate's 12, and it's for 5 years. And we divide all that by 100. So 9,367.2. So there we go. There's a depreciation of each of those assets. Okay, in question 7, what is the book value of the following items which are to be depreciated? Note that in each case we're going to have to work out the book value of the item, so that's going to mean working out the depreciation and then minusing the depreciation from the purchase price which we've been given here. So it's not going to be enough to work out the depreciation this time. We've then got to minus it from the purchase price to get the book value, because book value equals purchase price minus depreciation. Okay, so for part A, these are all it doesn't actually say if it's flat rate depreciation or not, but if we haven't been told otherwise, it seems reasonable to assume that. There's nothing to indicate that it would be anything other than flat rate depreciation, so that's what we've been doing. Let's keep doing that. It really should specify, but we have to make a kind of assumption here. So we know that it's going to be PRT over 100, so 12,500 times 5 years. The order is not important. I'll put the percentage first, but we really could have put the years in next. It wouldn't matter. And then divide it all by 100. 6250. So for A, we've got 6250. That's the depreciation, and then we've got to do 12,500 minus 62. So that was the D. So 12,500 minus 6250. Oh, it's exactly the same. So the book value 6250. Okay, in the next one we've got 6,321. Let's write it out properly this time. So D equals PRT over 100, and we've got 6321 times 5% times 3 years, and it's all divided by 100. So 6321 times 5 times 3 divided by 100, 948.15. That's D. And then we've got to do 6321 minus 948.15 to get our book value. So 6321 minus 948.15 equals 5372.85. 5372.85. and make sure we include the units, which are dollars. Okay, and I'm sure you can see how to do the other two, so I'll leave those for you to do, and we'll move on to question 8. Okay, question 8 says a clothing factory purchased a new machine for $21,600 with reducing balance depreciation at 16% per annum. We need to calculate the book value of the machinery after the first 4 years of use. So obviously this is a reducing balance depreciation problem, so we're going to need to use the reducing balance equation, which looks like this. The book value equals the principal times 1 minus the rate of interest over 100 to the power of n. Okay, so notice that this equation is going to take us straight to the book value of the item. It's not going to give us the depreciation, it's going to tell us the book value. So we're not going to need to do that extra step minusing the depreciation from the purchase price. It's going to take us straight there. So let's do that. Plug in the values. V equals P is 21,600, that's still the purchase price. 1 minus R is 16 over 100, and we've got to do this to the power of n. So n is 4 years, so we'll make it to the power of 4. So let's put that into the calculator. Yeah, and we're going to need to use the solve function, so we go action, advanced, solve, and then put in our formula, which is V equals 21,600, and then some brackets with 1 minus, let's put a fraction in there, so use the 2D option there and create a fraction. 16 over 100 is our fraction. Then we close those brackets, and then we've got to put to the power of n, and in our case n is 4 because it's the number of years. And then we've done our equation, so the last thing the solve function needs to know is what are we focused on. So we put comma and v to let it know that we want to know what the value of v is, and then we're closing the brackets for the solve function, and we press enter. We get the book value is 10,754.02. 10,754.02. Let's ignore that little point there. That's the book value of the machine after 4 years. Okay, in the next section, next question, we have to calculate the total depreciation over the first 6 years of use. So this time it's not the book value, it's the depreciation we need to work out. But in order to work that out, we're going to need to work out what the book value is and then minus the purchase price from it, and that difference will be depreciation. Okay, that's just a rearrangement of the equation that you've seen. V equals P minus D. Well, if we rearrange it to focus on D, because that's what we want here, total depreciation, if we rearrange this equation here to isolate D, then we end up with this equation. So we need to find the book value and minus the purchase price from that. Okay, to find the book value, we're going to use our equation again, this equation here, and this time we're going to put in the value of n is 6 years. So if we go back to our equation, we can actually go back to our previous line and just change the 4 to a 6 and then recalculate it, and we get 7588.04. So for B, we've got V equals 7588.04, and then we need to minus the purchase price from that. So take away 21,600, and you'll notice that this is going to give us a negative number because the purchase price is bigger, but that makes sense because the depreciation is a loss of value, so it should be a negative number. So take our answer and minus 21,600 from that, and we get negative 14,011. We don't need to write the negative because we know it's depreciation. So that's the depreciation of the first 6 years of use. Okay, but actually if we check the answer again, we notice that the cents actually bring us closer to $12 at the end than 11, so we should round this up to 12 here. Okay, in part C it says, after how many years does the machinery reach a value below $10,000? So they're telling us that the value of the machinery is going to end up at $10,000. That's the book value is going to be $10,000, and we want to know how many years will that take. So in this case, when we're doing our equation, V equals P 1 minus R over 100 to the power of N, this time we know the book value, we don't know N. So we're going to put the book value into our equation this time. So if we go back here to our equation, now we need to change V to be 10,000 because we know that's what it's going to end up at. What we don't know this time is N, so we're going to remove that 6 and replace it with N to show that it's unknown, and then tell the equation that we're interested in finding N. So that's what it's going to calculate. And when we execute that, when we press enter, we get N equals 4.42. So N equals 4.42, and that's in years, and that's what it wanted in years, but usually it's good to turn a decimal amount of years like this into a number of months. So we know it's 4 years, we don't need to change that into months, but we will change this 0.42 bit into months by going 0.42 times 12, and it's 5 months. So the answer is 4 years and 5 months. And lastly, the question says, after how many years does the machinery reach its scrap value of $3,000? So this time the book value has come down to 3,000, so we need to put that into our equation up here. The book value is no longer 10,000, it's now 3,000. Everything else is the same, we're still trying to calculate N, we want to know the number of years, and when we execute that we get 11.32 years. So N equals 11.32 years. Let's change the 0.32 into months. 0.32 times 12 is 3.84, which is pretty close to 4 months. So it's going to take 11 years and 4 months.